Welcome all to my YouTube channel Mechanical Study, where we study different mechanical systems. Today we are going to learn about psychrometric chart. So basically air conditioning processes like sensible heating, sensible cooling, humidification and dehumidification, those are the processes are better understood by studying the psychrometry. As you all know that the psychrometry is the branch of science where we study the properties of moist air or atmospheric air. So atmospheric air is a mixture of dry air and water vapor. Now this psychrometric chart represents all the physical and thermal properties of a moist air in a graphical form. There are different psychrometric properties that we already studied, such as specific humidity, then relative humidity, then so what is dryable temperature, wettable temperature. So these are the psychrometric properties that are better understand with the help of a psychrometric chart, and we can plot it on a psychrometric chart. So here we can see a psychrometric chart. On your screen you can see a psychrometric chart. Psychrometric chart basically consists of a different psychrometric properties like dryable temperature, then wettable temperature, dew point temperature, then specific humidity lines. So we will see one by one. On your screen you can see a psychrometric chart that is drawn at atmospheric pressure. It is drawn at atmospheric pressure, considering the pressure as a atmosphere, that is a total pressure. It is sum of a vapor pressure plus air pressure. So we will see the all those properties one by one. Here we can see a psychrometric chart. Psychrometric chart is basically drawn like such. Here on your screen you can see, here this horizontal line indicates dryable temperature line that we will see in the later slide. Then this line indicates the specific humidity lines. Similarly here we can see a saturation curve. This is called as a saturation curve. So we will see all those things in next slides. So here we can see a first that is a dryable temperature. So this horizontal line indicates a dryable temperature line. Here you can see it starting from the 20 degrees Celsius, it is in degrees Celsius, and it ends up to 105 degrees Celsius. Now here we can see these horizontal lines. So as we move from left to the right, the dryable temperature will goes on increases. So here a dryable temperature lines can be drawn by a vertical line up to this end line, which is represented by a, or which is shown as a specific humidity line. Then next is the wettable temperature line. Here we can see a saturation curve. This is called a saturation curve. Now on a saturation curve, here we can see a temperature that is 20, then it goes on increases along the saturation curve up to 85 degrees Celsius. So this inclined lines indicates about the wettable temperature of a air that is surrounding to us. So inclined line are drawn on psychrometric chart that is represented by wettable temperature lines. Then next is the saturation line. So here we can say saturation line. This is a saturation line or a saturation curve. Now on this saturation curve, here we can see along with that we can see on the right side a absolute humidity or a specific humidity lines, that is omega. This is a rather I will say specific humidity lines that is represented by a omega, and here we can see a dryable temperature lines that is measured in a degree Celsius. Now here we can see suppose there is the air which is at say 25 or rather I will say 35 degree dryable temperature, and say a 30 degree wettable temperature. So from this you can find out a dew point temperature as well as a specific humidity. If you draw a line from this point to the right side, you will get the specific humidity, and if you draw a line to the left side, you will get the dew point temperature. You will get the dew point temperature that for that particular condition. Then next is the relative humidity line. So as you all know that the relative humidity is measured in percentage. So this saturation curve is also called as a 100% relative humidity line. Then is here we can see a relative humidity line will goes on decreases as you move rightwards. So it will 100%, then it reduces up to 20% towards the end. So this is the lines that are generally curved like such, that are drawn, and as you move from left to the right, then it will goes on decreasing. Next is the specific humidity lines. So on your screen you can see a specific humidity line. So specific humidity lines, generally this, here you can see a specific humidity that is represented by omega. Here you can see a horizontal lines, these are called as specific humidity lines, and generally it is measured in gram per kg of dry air, gram per kg of dry air. The next psychrometric term that we have to know about is the dew point temperature. As earlier I have told you that whenever we know the dryable temperature and wettable temperature of air, we can easily find out the dew point temperature. That is, suppose here the condition of air is represented by this point, then if you draw a line leftwards, we will get the dew point temperature. The line where it crosses the saturation curve, that point will be gives us a dew point temperature. And dew point temperature is the temperature at which condensation of the water vapor in the air starts, and whatever the line that we will draw towards the right and which will cross our specific humidity line, which is gives you a omega, value of omega, that is in kg per kg of dry air or gram per kg of dry air. Then next is the specific enthalpy. Now as you all know that the specific enthalpy, as you already derive in earlier lectures that we have already studied, in that also we know about the specific enthalpy. Here we can see a specific enthalpy scale. It starts from 10 up to 50. Its unit is kilojoule per kg of dry air, per kg of dry air, kilojoule per kg of dry air, and it is also drawn by inclined line. It is also shown by inclined line on psychrometric chart. So this will gives us a value of a specific enthalpy for any condition of a moist air. Just we have to first of all plot a point, then we have to just extend that point up to the specific enthalpy scale, the point where it crosses the specific enthalpy scale, where you get the desired answer of a specific enthalpy. Then next is the specific volume line. So specific volumes line again drawn by inclined scale, and it is unit is meter cube per kg of dry air, meter cube per kg of dry air. So it is drawn by inclined line on a psychrometric chart. So on your screen you can see a specific volume lines. Then there are different air conditioning processes that are generally carried out in air conditioner, like sensible heating. Here we can say sensible heating, and generally that is plot on the psychrometric chart. This is the psychrometric chart, this is the omega, then this is dryable temperature line, horizontal one. Then here we can have a different wettable temperature lines. Along with that also have dew point temperature lines. Then here are the specific enthalpy lines. Okay, so these are all those psychrometric properties that we can plot on psychrometric chart. Now the very important point that is discussion is the psychrometric processes, basically psychrometric processes. So basically in air conditioner different processes are carried out depending upon the season. Now in suppose if I have taken an example of India, where the maximum of the air conditioners is needed in the summer conditions. So basically in India the air conditioner are designed in such a way that the process that is carried out in air conditioner is basically dehumidification and cooling. As you all know that in winter basically the humidity in the air is much more higher, and along with that the temperature of the air is also very high, that is in the range say 35 to 40 degrees Celsius. In some region it may be above than 40 degrees Celsius. So for that purpose in India in maximum of the states air conditioner are basically designed for the summer air conditioning system. So basically in summer air conditioning, the process that is carried out in a air conditioner is dehumidification with cooling. Okay, we just have to dehumidify the air and cooling so that the desired temperature in the room will be achieved. Now this is the example of a summer air conditioning system. So likewise in a winter also, the requirement of for a human comfort is that the in the surrounding air, the humidity in the air will be lesser in winter condition. So our skin will be gets dry in a winter condition. So for that purpose, in winter we need to for air conditioning system, we need to humidify and heat the air in order to maintain the temperature and the humidity inside the room condition. So for that purpose, in a winter condition, we need to heat and humidify the air. Similarly, in areas like Rajasthan, where the condition is such that the humidity in the air is very less. So for such areas, we can use coolers also. That is a air coolers that we can use. So there will be no necessity of air conditioner in those areas like Rajasthan, that is a desert area. But in some of the areas like Mumbai, where the humidity in the air is very much high, so there also we have to use air conditioners in such a way that as you all know that the Mumbai is a type of a city where the sea is nearer to it. So basically, in many of the months of year, the humidity in the air is much more higher as the sea is nearer to the city. So for that purpose, and we need to design an air conditioner in order to dehumidify the air, as the humidity in the air is too high, and the population is also very much more as compared to other city. So basically, air conditioning systems are designed in such a way that the as per the condition of the surrounding, we need to choose the air conditioner and whatever the psychrometric processes, so that the human will feel comfortable, and those processes are generally carried out in the air conditioner. Those are the parts that are generally installed in the air conditioner, so that those processes will be carried out and desired temperature and humidity will be maintained inside the room. So basically on a psychrometric chart, here we can see different processes. So here we can see there are different psychrometric processes like sensible heating, then sensible cooling. Here we can say sensible cooling process. In sensible cooling process, what happens, we generally decrease the temperature of air, that is the dryable temperature will be decreases. In sensible heating, dryable temperature will be increases. So in basically sensible heating process, we need to have a heating coil in the air conditioner. In a sensible cooling process, we need to have a cooling coil or a refrigerating coil in the air conditioner equipment. Now next is the humidification process. Next, that is the psychrometric process, the humidification. So humidification process, in humidification process, what happens, we increase the specific humidity of the air. Here we can say the suppose this is the process 1 to 2. So here the process that is known as humidification process. So in humidification process, we generally increase the humidity of air. So humidity of air may be increased by the addition of moisture. So arrangement will be done in such a way that the moisture will be added in the air, and so that the humidifier air will be supplied to the room. Then next is the psychrometric process, the dehumidification. Next is the dehumidification. So in dehumidification process, basically we need to remove the water vapors from the moist air. So in order to remove the water vapor from the moist air, we can use absorbent or adsorbent, so that water vapors can be absorbed, or rather we can cool the surrounding air below its dew point temperature. Means if you cool the air below than the dew point temperature of the incoming air from the surrounding, so that the temperature as decreases below than the dew point temperature, then what happens, the water vapor will start condensing, and at the same time dehumidification process can be carried out as water vapor gets separated from the air. So basically this is the process generally that is carried out in the summer air conditioning. Basically a cooling coil is designed in a such a way that the cooling of a surrounding air is done below the dew point temperature, so that the simultaneously cooling as well as dehumidification process can be carried out. As we decrease the temperature of a surrounding air below than the dew point temperature of the air, as you all know that the temperature goes below the dew point temperature of the air, so its water vapor in the present in the air will start condensing, and it will get separate out from the air that is passing over the cooling coil, and it will be supplied further to the air conditioning room. So basically in summer air conditioning we perform cooling and dehumidification process. This is the cooling and dehumidification, that is cooling and dehumidification. So dehumidification process can be drawn like such, and cooling is drawn like such. So this is the process that is basically drawn. The next is heating and humidification. So this is the process that is generally carried out in winter condition, that is heating and humidification. As in winter condition, the as you all know, the temperature is much more below than the comfort temperature of a human body. So for that purpose we need to heat and humidify the surrounding air in order to in order to maintain the temperature and humidity inside the room. Similarly, as you all know that a separate humidification and dehumidification process are not needed in any air conditioning applications. A combination of all those processes that is needed, such as here you can say cooling and dehumidification and heating and humidification process. So these are the generally psychrometric processes that are generally carried out in a air conditioner equipment for the purpose of human comfort. Apart from that, for industrial air conditioning also depend upon the requirement, like in if you take an example of a paper industry, so where or rather I will say printing industry. In printing industry also we need to maintain a proper humidity and a temperature and the temperature inside the industry, so that the a proper humidity will be maintained, and so that there will be no blur that is appear on the paper or a printing paper. So these are the basically the application of air conditioning in the industrial area also. Basically so apart from that, in different industries also basically air conditioning system can be used apart from the printing industry. So these are the basically applications of rather I would say air conditioners in a different areas. First of all, we study the applications of air conditioning in that is for a household application, that is for the human comfort. And for human comfort, as we all know that it can either we have to perform cooling or dehumidification process in summer air conditioning, and heating and humidification process in winter air conditioning. So basically these are the processes that are generally drawn on psychrometric charts. So this is a psychrometric chart where we can draw different processes, and as we all know that whenever we buy a air conditioner, we generally buy with the ton requirement. Means we buy either 1 ton of AC, 2 tons of AC. I am taking an example of a split window air conditioner. So the main markets we are having availability of 1 TR AC to 2 TR AC. So basically whenever we buy any air conditioner, in random sense, if for 10 by 10 room, we generally prefer 1 ton of a air conditioner. So this is not the actual calculations. In actual calculations its value maybe comes out to be different, but in general, that is in a random sense, if there is a 10 by 10 foot of a room is there, so for that purpose we can randomly select 1 TR of a air conditioner. And there are also different calculations that we can perform in order to select an air conditioner, that is whatever the capacity of air conditioner that we have to select. that we can select for our room. So this is all about the psychrometric chart. Basically all the psychrometric processes like heating, cooling, then humidification, dehumidification. So these are all those processes that we can draw on psychrometric chart for the purpose to estimate the cooling load estimation. So basically what is cooling load estimation? So cooling load estimation, that is generally for used for the purpose to select an air conditioner for that particular application. So basically as per the different applications, we can select a air conditioner as per the load on the load of the system. So this is all about psychrometric chart and psychrometric processes. So do like and subscribe to my channel. Thank you.